Welcome to our presentation on the combined gas law. Here you'll learn all about the basics and the fundamentals. So listen up, we're about to go on an exploration of the combined gas law. Let's go!
The combined gas law is the result of the combination of three gas laws: Charles' law, Boyle's law, and Gay-Lussac's law. Hey Norbu, what are these three laws exactly? Go.
I'm glad you asked, Elijah. Boyle's law describes the relationship between volume and pressure, while Charles' law describes the relationship between temperature and pressure. In addition, Gay-Lussac's law is the volume and temperature relationship. Without these rules, we would not be able to derive the combined gas law, as it requires all three variables of temperature, pressure, and volume.
Well, doesn't that make you just want to go out there and do some practice problems? Science really can be beautiful.
Of course it is. The combined gas law is... As you can see, all the laws are reflected in this. It highlights the important interactions between the various characteristics of gases. Practice problems are really the best way to understand how these work together.
It's really helpful in solving for gas-related problems and understanding the behavior of gases. Given two of the variables, you can always solve for the third. Be sure to keep in mind that temperature must be in Kelvin. So to convert Celsius to Kelvin, add 273 to the Celsius value to get your value in Kelvin.
Similarly, we know that when one variable changes, the others must compensate as well. Therefore, the rule of P1 V1 over T1 is equal to P2 V2 over T2 can apply. Since you will need help, we'll work through a practice problem, the combined gas law, just for you.
So here's a practice problem. Solve for V using T and P. If I have 18 liters of gas held at a pressure of 85 atmospheres and a temperature of 800 K, what will be the volume of the gas if I decrease the pressure to 44 atmospheres and decrease the pressure to 672 K? So as you can see, I'm writing down the combined gas law equation, and from there I'm going to substitute the values into the equation. As you can see, the initial values of P and V and T are given, so that means you can put in the 85 atmospheres times 18 liters of gas all over 800 K. Make sure everything is in liters and in Kelvin, but the pressure doesn't really matter. And so on the other side, you're going to want to put your final values, your changed values, as I'm doing here, and what you're going to be solving for this time around is volume in liters. So pretty much what you're going to want to do is you're going to want to get the variable by itself, and to do this you're going to have to do some algebra by multiplying 672 by both sides to cancel it out on the bottom, and what you get is 44x is equal to this large number, and if you calculate it out on a calculator, it's 672 times 85 times 18 divided by 800, and I'm just calculating it on the calculator right now. And you should get around 1285.2. And so you just divide by both sides for 44 to cancel out the 44x, and so x, when calculated, will give you around 29.20. And make sure to label, because I forgot to do that, and you'll probably get marked points off. And that was the combined gas law. We really hope this presentation has helped you, because it really will help you in regular chemistry and even in AP chemistry if you choose to take that class. We hope you had fun, and we'll see you next time.